Hi, it's Mr. Springer again, chemistry teacher. And in this video, we're going to talk to you about um, writing names for simple ionic compounds. And it'd be good for you to have a copy of your periodic table handy. Again, I'm using this one that just has a few of the elements that I like to use, but there's no reason why a complete table wouldn't work. I have changed this if you watched videos in the past. Lead acts sort of like a transition metal in that it can be a +2 or a +4 charge frequently. And so I've made that adjustment. It really doesn't play any role in today's video, but it is something that I've changed since last time. You may also need a copy of some polyatomic ions. Here are some that I like to use. You may have a similar list that your teacher's given you. Sometimes teachers want to memorize and sometimes they don't. So we'll carry on from there. The naming for the ionic compounds is really not too bad. For the most part, the subscripts really don't matter for most unless it's one of those transition metals that we've talked about earlier. But for the most part, it is very straightforward. You just name the metal first, followed by the nonmetal, and you change the ending to IDE. So here's one. It's CaCl2. Ca, of course, is calcium. And the Cl2, that's just a chlorine ion, so we will call it chloride. Calcium chloride, all there is to it. Na2O, Na of course would be the sodium ion. And O is oxygen, but as an anion it would be oxide, sodium oxide. Very straightforward, nothing too shocking here. Alright, here's some zinc, and bromine would be bromide. All of these that are binary and with the letters IDE, that's kind of a tip-off that it is binary. One exception to that, sometimes you'll see hydroxide, which also ends with IDE, so that's one that makes it a little more tricky when you get into the more complicated ones. Here we've got Mg3N2. Again, subscripts really don't come into play in the naming except for the transition metals. This is magnesium nitride. Again, see the IDE ending. All right, here's one. It's copper, and remember, copper might be a +1 or it might be a +2. So we have to figure out which is which. So here we got 2 coppers with 1 sulfur or sulfide ion. It's going to be copper. We're going to need a Roman numeral. And the name of the sulfur would be sulfide. So it's copper something, sulfide, and the Roman numeral is the charge of the copper. Now, how do we figure out whether it's +1 or +2? Don't just see the 2 and automatically put a 2 here because that subscript is not the charge on the copper. The subscript could be, it's closer to the charge on the sulfur than it is on the copper. Okay, so if in fact, if you look at if you've labeled these, sulfur is in the -2 column. So I'm going to go ahead and call that a -2. The copper has to balance the -2. We have 2 copper ions to do that. So each one of those 2 copper ions must be +1. So +1 times 2 would be +2 for this side. We got -2 for that side. The +2 tells me this is copper 2 sulfide. Again, with the sulfide, we know it's -2. This time there's only 1 copper atom, or copper ion to go with that, excuse me. So if the sulfur has to be -2, the copper then, to add up to 0, +2, copper 2 sulfide. Again, don't forget your IDE endings tells us that it is binary, only 2 elements. Not 2 atoms, 2 elements. So we got 3 atoms here, we got 5 atoms here, but it's only 2 different elements. When we get more elements involved, then that's where these polyatomic ions come into play, and you need to be starting to recognize when you see these in a formula Sometimes they have parentheses if they need it. Sometimes they don't. Like for example, on this first one here, K2SO4, there are no parentheses around the SO4, but SO4 is the sulfate ion in this case. So I don't mind if my students put a parenthesis around the SO4. Really doesn't bother me at all. So I know that's sulfate. K is potassium. SO4 is sulfate. And it's as easy as that. Here we've got a PO4. This is in parentheses because we needed 2 of them to balance out the charge for the 3 calciums. We needed 2 phosphates. Phosphate is a -3 ion. So calcium phosphate. And it really, again, only the ones that are the transition metals, the one with more than one charge, do we even care about the subscripts at all. Okay. NaNO3, here's my NO3 with the -1 charge, that's nitrate. Again, I don't mind if you want to put it in parentheses to help you recognize that. They're not always going to show up that way. Sodium nitrate. Be careful, if it were NO2, it would be nitrite, but it's NO3 in this case, so it's nitrate. The ate ending always has one more oxygen than the ite. Nitrate, NO3, nitrite, NO2. It's not always 3 are 8s. Here, SO3 is sulfite, SO4, sulfate. Whichever one has more O's is the ate ending. Whichever one has fewer is the ite ending. Here we got chlorate with ClO3, chlorite, ClO2. Be aware of that. Here we have silver acetate. Be careful on the acetate. Sometimes they write it differently. CH3 COO minus is sometimes written for acetate. I like the C2H3O2 myself, just personal preference. Now we've got the iron, which is a transition metal, which may be +2 or maybe +3. We're teaming it up with the ClO3, which is chlorate with a -1. It's iron, something, chlorate. We know the chlorate is -1. We have 2 of those chlorates, so this half of the molecule of the formula has a -2 charge. So the iron, in order to balance it out, must be a +2. So it's iron, Roman numeral 2, chlorate. Here we've got a chlorite, ClO2, which has a -1 charge. -1. We have 3 of those. 3 -1s would be -3. This iron then must be +3 in order to balance it out. Iron 3 chlorite. Okay, well, I hope this helped, and I look forward to seeing you again at some point.